Hello friends, welcome back to our channel. This is part 3 of Digital Design Interview Questions and Answer Series, Skipping of Pulses. In part 2 we discussed if you want to skip nth pulse, how to skip that, and I gave you the solution as well. And at the end of that video, I asked you one question and that question I kept unanswered. In this video, I will give you the solution of that question. But first of all, let us see what was the problem statement. The problem statement was you have to design a logic to skip two pulses at different locations. Let us see the waveforms. So this is the problem statement. In this problem statement, I am asking you to skip two pulses at position 3 and 7. So this is the first pulse, second pulse, third pulse. So this we have to skip. 4, 5, 6 and 7th pulse also we have to skip. Otherwise all the pulses will propagate at the output. So this is the problem statement. Now you have to design a digital logic which can serve the required functionality. You can pause my video here. Try to think of its answer. If anything comes to your mind, please write it down in the comment section. Otherwise I am going to reveal its answer. Let us see the waveforms first. This is clock. This is input pulses. This is expected output. Here I am taking a counter. Counter will increment whenever input pulse is received. So previously counter value was 0. When first pulse is received, it will go 1. On the second pulse it will go 2. Third pulse it will go 3. Fourth one it will go 4, 5, 6, 7 and so on. But here we have to latch the value of counter at 7. So whatever is the bigger value, for example, the pulses that are to be skipped is 3 and 7. So we have to latch this counter value at 7. Now I have to generate a comp underscore op, one output signal which will depend upon the counter value. So whenever counter is 2 and 6, that is n minus 1. So n was 3 here, n minus 1 2. So at position 2 I will make it 0. Similarly n is equal to 7. So n minus 1 6, so we will keep the signal high 0, otherwise the signal will remain high. Now how to achieve the required output? So comp underscore op I will AND with IP. IP AND with comp underscore op. So when first pulse is there, it will be propagated. Second pulse will be propagated. Third pulse, because this comp underscore op is 0, it will be skipped. Similarly, this will be skipped. All other pulses will be passed. Friends, now let us see the logic design. Friends, the logic design is very simple. This is a counter. This is the input signal where input pulses are coming. Whenever any input pulse comes, counter will increment by value 1. And whenever the counter value reaches 7, it will latch it. Then it will not increment further. So this count is applied to a comparator. Whenever count is not is equal to 2 and count is not is equal to 6, comp underscore op will always remain high. And this comp underscore op and this input is applied to AND gate and we will get the final output. Friends, one more thing I want to ask you, why I am latching the counter at 7. If anything comes to your mind, please write down in the comment section and we can discuss it there. Similarly, the same logic can be applied if you want to skip 3 pulses, 4 pulses and so on. And I am not going to create a separate video on that. So please extend this logic to skip 3, 4, 5, 6 and so on number of pulses. With this I am going to end this video. If you liked it, please press the like button and share your feedback in the comment section. And in future also we are going to create many such videos. So to be aligned with our channel, don't forget to subscribe it and press the bell icon to get the notification of all the upcoming videos. Thank you so much for watching and your time.